How are your paper airplane skills? Choice number 3 in science asks you to plan and carry out a fair test in which the variables are controlled and failure points are considered to identify aspects of a model that can be improved. So the idea is not just to make an airplane and fling it around, but to try and improve upon your model and use some science knowledge to make those improvements. So what you're going to do is watch a couple videos, and you're going to learn about the science involved in flying. So the first one has to do with Bernoulli's principles. Now, Bernoulli was a scientist who discovered that air, like liquid, is fluid, has properties of a fluid, which means that it can move through channels, and that it also can fill a space that it's in, a variety of spaces. So it has that fluidness to it. And that was very important in flight. So Bernoulli's principle is one of the scientists that were instrumental in flight and understanding flight. And the second one was Sir Isaac Newton, and I know that you're familiar with him. So he had 3 main laws, but the first and the third have to do with flight. So the first law says, and you'll remember this, an object in motion will stay in motion unless there is an outside force that prevents it from continuing. So I want you to think of what the outside force might be that would stop your paper airplane from flying. And I'll give you a hint, there's 2. So 2 forces that are going to restrict that plane from flying forever and ever. And then Newton's third law talks about for every action, there is an equal and opposite reaction. So I want you to think about what that might be with your paper airplane. So you can have that discussion maybe with your family at home. So, and you're also going to learn about the 4 forces of flight. And this is extremely important for any of you interested in ever becoming a pilot. You need to understand these. So you have thrust, and that's the plane moving forward, but you also have drag, and that's preventing the plane from moving forward. You have lift, that's what keeps the plane up, but you also have weight, that is caused from the force of gravity pulling it down. So you have these 4 forces constantly acting on your paper airplane. So it will be fun to observe that while your plane is in flight. All right. So what you're going to do is watch these videos to get inspired and learn a little bit about the science behind a paper airplane's flight. Oh, you're also going to learn about center of gravity, which we did a Magic Monday in, and that's brought up again too. So you want to pay attention to that. Science, a lot of science involved in flying a paper airplane. Serious business. So you're going to design and build a paper airplane. You can base it off one that you learn in the videos, or you can come up with your own design or do a modification. And then I want you to think about the constraints. Again, they're always materials, time, and cost. So you're going to have to use the type of paper that you have at home. You're going to have to, it's however much time you have to invest in this, and cost. Well, we're going to keep that very simple. It's basically a piece of paper. And then I want you to record on this slide what was the longest time in seconds your plane stayed in the air. So you can time it on a watch, or maybe you have a phone that you can use the stopwatch on to time it. If you don't have those things, you can do the 1 Mississippi, 2 Mississippi, 3 and just count your time. So record your time in seconds there, and we'll see who can keep their plane in the air the longest. And then what modifications did you make to your plane? I should see at least 1, more like 2 or 3 modifications. That's going to show me how much effort and energy you put into this design process. And then attach a picture or video of your plane in flight if you can. That would be awesome to see that. All right, this is going to be super fun. I hope we get some nice weather so you can get out and fly your planes. If you can't get outside to fly them, just fly them inside. And think about what would be the difference if you flew your plane outside versus inside. There's a key variable that's going to be different. So actually, maybe we should say all the planes should be flown inside, but how many people have a big space? There's some engineering design challenges right there that we're going to have to work through. So just have fun with it, make it work, okay? I'll be anxious to see those.